Oh my gosh, I am so excited because we are finally to the fourth and most important of all conic section called hyperbolas. Hyperbolas. I searched the web forever to find you only the best pictures that illustrate in nature what a hyperbola looks like. And here we go. This one is the pièce de résistance. It is the shadow of a lampshade on a wall. You'll recall that a hyperbola is the result of an intersection between a plane and a double-napped cone. It slices it almost vertically in two different places so that it has a lot of symmetry through its axis, and also there's one that's up. So it's, in other words, it's a double parabola. I mean, it just doesn't get any better than that. All right, let's get down to it. As you can see, hyperbolas are different from all the other conic sections. In fact, all of them have differences and some similarities. Its eccentricity is the least like a circle, so it's going to be greater than 1. Hyperbolas make use of vertices and covertices like an ellipse. They also have foci, 2 foci, like an ellipse, but they're more like a parabola in that their foci are going to be inside the curve. So I've drawn this map here, and what I've shown you is I'm going to draw them 2 different ways, but first time I'm going to put the vertices on the x-axis. This one has a center of 0. And then you'll notice here that they have asymptotes. There's also a box. You can see the box here. So here are the vertices. And these right here are the covertices. And it's the covertices and vertices that make the box. And then the next thing I want you to notice is that the asymptotes go through the corners of the box. So if you just continue on horizontally and make a lovely rectangle, these will be the asymptotes. The foci, just like in an ellipse, are on the main axis. And the the hyperbola actually looks like this. So it passes along the asymptotes without crossing them, and then passes through the vertex. So we have an additional thing here in that we have the equations of the asymptotes. So the equation of a hyperbola that looks like this is x minus h squared y minus k squared equals 1. Okay, and as we write it like this, it looks almost like an ellipse. In fact, it is an ellipse because this should not be a plus, that should be a minus. Okay, and then over a squared and b squared. A, once again, is the distance from the center, to a vertex. That's the distance. And then the b is from the center to, it's a covertex, but that's what we use to make the box. So this distance here is A, and this distance here is B. And you can see on this diagram, A is not bigger than B. So actually, in a hyperbola, the point that is the furthest away from the center is going to be the focus. So c squared is going to equal a squared plus b squared. In other words, c squared is going to be the largest. This is not the Pythagorean theorem. This is a relationship between the distances a, b, and c. A, B, and C, of course, in the Pythagorean theorem are in a right triangle. This is not a right triangle, okay? But that relationship still stands. All right, so if we're going to write the equation of the asymptotes in this, what I want you to notice is that the slope of this line, right here, this line, is up, rise over run, right, over B, up B over A. And then this one is also up B over A, but it's negative. So the asymptotes are going to be y equals plus or minus, they're lines. The slope of the line is going to be b over a, times x. So these are, asymptotes are lines, once again, so you have to have the equation of a line, vertices and covertices. All right, if you switch directions, that means that your major axis is going to be first. Since it's y, it's going to start out y minus k squared, and I did plus again, minus x minus h squared equals 1. A squared is still underneath the first. A squared is still first. C squared is still equal to a squared plus b squared. And the asymptotes this time are going to be y equals plus or minus, this time the slope is a over b. Positive and negative, a over b. So I have a over b x, and those are the equations of the asymptotes. So on the future on future slides, I'm going to actually graph these so that you can see how all this works together. But I want you to get the general idea and the shape. Realize that this is the major axis, whichever one is first, and it's because that negative is there. This is still a squared and b squared, and you can use it to find c squared. Okay, we're going to start off with a fairly simple example. And we have the center at 0, 0. So that's very nice to have a center at 0, 0. We know that a squared is the first, so it's 16. B squared is the other number, that's 25. C squared is going to be 25 plus 16, which is 41. So A is plus or minus 4, B is plus or minus 5, and C is plus or minus 41, which is a little bit less than 7. So I'm going to go ahead and graph this. And the first thing I want is A and B. A is on the x-axis, so I go 1, 2, 3, 4, and put a point. 1, 2, 3, 4. Then I do the covertices, and I'm going to go ahead and put these there so I don't lose track. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Covertice, covertice, draw a box. So go up, over, up, over, and I have my box. All right, the asymptotes go through the corners of the box through the origin. So I have one that goes here, and I have one that goes like this. Takes a little bit of practice. You can use a ruler. Okay, so I didn't write covertices on there, but I did put where the vertices are. So I can draw in my hyperbola. Not bad, free-handed. And the last thing I have to do is put in the foci. So I'm going to move, I said what, little 7's the furthest away. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's a little less than 7, isn't it? Anyway, I'll put that on there and move that over to there. All right, so there's my graph. The last thing I have to do is list all these points. So I really just need the vertices, the foci, and the asymptotes. Okay, so I know here that this is B and this is A. So the asymptote is going to be at B over A. B is 5. A is 4, x. So I'm done. The vertices are going to be at plus or minus 4, 0. And the foci are going to be plus or minus square root of 41. Caught it. Caught it. You're not going to tell me, oh, and then I wrote a theta. There we go. 0. 0. Okay, so that's the problem. And so you have all this information over here that's listed just like we did for the ellipse, and that's your first example. We can work this backwards. We can actually find the equation from a graph. And so we need two things. First, we need to know which axis the hyperbola goes through, which of course is x. So we're going to be using this formula. Okay, so I need the center. Well, the center, that's HK, right, is going to be at 0, 1. The vertices are how far away. So I'm going to count 1, 2, 3, 4, 5 away. So that means that A is plus or minus 5. So that means A squared is going to be 25. Now I need B. B is going to be plus or minus 1, 2, 3, 4 from the center. So B squared is going to be 16. So I have everything I need to write the equation. I'm going to have x minus 0 squared, so x squared, minus y minus 1 squared equals 1, all over, which one comes first? A, so this is 25 and this is 16, and we're done. So that's how you write the equation from the graph. Okay, we've been completing the square now for a while, so I'm going to work one more of these problems, and then that'll be it. The first thing, of course, that we do is that we put things in order, all right? And further, with a hyperbola, we also have to take into consideration the minus sign. So I have 9x squared minus 36x, I hope I don't run out of room, minus y squared minus 6y equals negative 18. All right, so, we're going to factor out a 9. So this is x squared minus 4x. We're going to factor out a negative 1. This is y squared plus 6y equals negative 18. And then take a quick double check. Okay, so I'm going to complete the square. I'm going to say x minus 2. I'm going to square it. That gives me 4. I'm going to multiply it times 9 and get 36. I'm getting 300 text messages. I have no idea why. I have y plus 3, and I'm going to square that. And that's going to give me plus 9, but it's not plus 9, it's really minus 9. So I'm going to get 36 minus 27, which is, I have no idea, 9? Yeah, 9. Lovely, 9. So then I'm going to divide everything through by 9, and I'm going to end up with x minus 2 quantity squared minus y plus 3 squared equals 1. This will be over 9, and this will be over 1. So my a squared is 1. A is plus or minus 1. B squared is 9. B is plus or minus 3. C squared is 10. And C is plus or minus the square root of 10. And I'm gonna leave off on this. This is, I believe, one of your problems in your homework. So this is a good start. What you have left to do is you have to sketch a graph. I have no idea what I just wrote there. You're going to sketch a graph, and then you're going to list the vertices, the foci, and the asymptotes for homework. So if you'll go ahead and finish this in your notes, when you get to number 19, you can say, all done. Okay, well, this is the end of this video. One thing I would like for you to begin thinking about, if you haven't already, hopefully you have, are the similarities and differences in the conic sections. How are they alike? How are they different? I can have the equations up on the board, up on the wall, you know, where I keep them written. But if you don't understand how they work, it won't help you on a test. So begin and continue to study these as we go along. It will make things a lot easier. I believe this is the last video I'm going to make in this unit. So I hope you've enjoyed it, and I will see you in class.